All right. So what do you think happens, guys, when I add a neither to a neither? It kind of seems conventionally it would be neither. Let me show you an example where that's true. Here's a neither. If F was can you see that that's neither? Because that part is an even, right? And what is 2? I'm sorry, that's an odd. X cubed is an odd. 2 is like 2x to the 0 power. 0 is an even power. So that's an even. What's an odd and an even? When you add them, neither. So that makes sense, right? Now watch this. What if G is x squared plus x? Is that a neither? Yeah, because you have an even added to an odd. X to the first is odd. 2 neithers added together where you end up with what? Odd, even, even, odd. That's totally a neither, isn't it? So there's an example where that be true. A neither plus a neither is a neither. But now what if this was the case? What if G was this? Is that still a neither? It's not? X cubed, no, this part I'm pointing at. That's still a neither, right? So what happens now when you take a neither added to a neither? You get nothing. What is 0 considered? Constants are even because it's like 0 x to the 0 power. I can always say a constant is times x to the 0 power, and that would be a 0 power. Or think about it. If I said y equals 4, isn't that a horizontal line? Doesn't that have y-axis symmetry? So any constant function has y-axis symmetry. So this is equal to 0. This is an example where a neither plus a neither is equal to an even. And then what about this? What if I said this was my function? This is a. Actually, I'm not sure I can do that. Hold on. Okay. Neither. Two neithers added together. What happens? You're left with x, and what is x? Odd. X to the first is odd, first power. So you can see if I don't know what the functions are, and somebody gives you something like this and said, what kind of function would remain, even, odd, or neither? The answer is it could be even, could be odd, could be neither. You really don't know much on the neithers. But if I took a neither and added it to an even, it's going to stay an even. A neither. If I took a neither and added it to an odd, it's going to stay a neither. But when you put a neither and a neither together, who knows what's going to happen? And that's true for addition, subtraction, division, all that stuff. But that's more of a math team topic when they throw out the neithers in there. Are y'all with me? And then somebody said, did anybody else have a question on the homework? Honestly? Nobody? We good? Okay, well then let's jump to graphing. All right, so graphing trig functions. I am going to do something at the very beginning that I pray none of you do, because if you try to do it, you'll never get anywhere and you'll get destroyed on the steps. And I mean destroyed, majorly destroyed. But I'm going to plot points to graph this, just to show you, one, how painful it is, and two, how you just don't want any part of it. But I'm going to do it right now just to show you that these little patterns for sine, cosine, negative sine, negative cosine are not tricky. They're not like something made up. It actually comes from something. So for me to graph this, y equals sine x, what does the x stand for in this problem? You're going to be signing it. So what is the x? It's an angle. Good. It's an angle. We're just not using theta because I want to put it on an xy axis. So x would be the angle. And what would the y be? Which ends up giving me the, when I sine an angle, what do I get? So the ratio of those two sides, right? So that would be the opposite over the hypotenuse. If it's cosine, the adjacent over the hypotenuse, whatever. So the x right here is going to be my angle, and the value I get out of it when I sine something, the y would be my ratio. So I think I can use unit circle angles might make that easier on me. I wouldn't have to pull out a calculator. So let's just make a chart. Pretend you don't see the graph there. Let's make a little XY chart. And this is how painful it would be to graph. Please don't ever do this. So I'm going to start walking through my unit circle values. Now, I can't use degrees because what do you see on my number line? 3.14, 6.28. What does it look like that is? Pi and 2 pi. So I'm going to go, all right, I'm going to start with 0 radians. Go to my unit circle. What happens when I take the sine at 0 radians? The sine is always which coordinate? The y. So what is my coordinate there? 0. So I need to mark 0, 0, and there we are. There's our first point. Now, remember, 3.14, that's my pi. So that means if I want to get to pi over 6, I got to divide that pi into 6 parts. You kind of follow me? Which is not very fun here. So I would probably divide it in half and then divide that part into thirds. And if I do that, I get the 6th. So the first radian, remember, you're not going to be doing this, so don't worry about it. But first thing I go to is pi over 6. What's the sine at pi over 6? Up a little, right? A half. So I need to go up a half at that pi over 6, and that would get me that point right there. And then what's the next one up from pi over 6? Pi over 4. Pi over 4 would be in the middle of those two middle dots right there. And that would be pi over 4. Now, this is where it starts getting annoying. What's the sine at pi over 4? Root 2 over 2. How much is that? So you right now, if you don't know what root 2 is, you ought to burn into your brain that root 2 is about 1.4 and root 3 is about 1.7. I mean, it's an irrational number, but it's about that. That will help you think. And it will help you think in a lot of other ways more than just today. So right here, what is 1.4 divided by 2? Over 2 is about what? 0.7. So at pi over 4, I'm going to go up about 0.7. It's kind of hard to tell what that even is. But anyway, so then I move on from what? From pi over 6 to pi over 4 to pi over 3. What's the sine at pi over 3? Square root of 3 over 2, up a lot, right? Up a little. Root 2 over 2, up a lot. Square root of 3 over 2. What's 1.7 divided by 2? 0.8-ish. It's really like 0.86-ish. So that's really like 1.72-ish. But whatever. About 0.8. This was about 0.7, right? So I'm going to go right there, up about 0.8. And then what comes up after pi over 3? Pi over 2. What's the sine at pi over 2? Straight up. 1. That gets you to the top. Now, what do you notice coming down the other side of that unit circle? What are the y values on the second quadrant? The same as. Y'all not notice that? I mean, like at 60 degrees and at 120, aren't we going up the same thing? At 45 and 135, aren't we going up the same thing? So as I'm coming down, couldn't I go, all right, well, at the 2 pi over 3, I'm still at that 0.8-ish. And at the 3 pi over 4, I'm still at that 0.7-ish. And at the 5 pi over 6, I'm still at the 1/2. And at the pi, I'm back down to 0. I'm trying to save you a little more pain and suffering. And then what happens is I roll down into the third quadrant and the fourth quadrant. What changes there? The first quadrant, I had all positive y values. The second quadrant, I had positive y's. But in the third and the fourth, I'm always got negative y's, right? But are they going to be the same thing but negative? Aren't they? Proportionally. So I can go through here and now mark the negatives, the negative, the negative, the negative, the negative, the negative, the negative, and then back to 0. I can do this, and then I move on to the next. Once I get past 2 pi or 360, isn't 390 coterminal with 30? Isn't it still going to be up a half? So what ends up happening over the next 2 pi or the next 360 degrees? I get the same wave, don't I? Guys, this sine curve is what we call periodic. All the trig functions are periodic because as I go through the next set of angles, they're all coterminal to these. So the y values will match even though the x values are different. So different angles, but same trig functions. So you get the same period. I hate plotting points. I like to notice patterns and get it done. And you're not always going to have a nice, simple sine curve like that. What you're going to be graphing in here is something like this. Y equals -4 plus 5 sine of 3x minus pi over 7. And if I give you this, you are not going to want to plot values. Because even if you plug 0 in here, like, oh, I plugged 0 in the first time because sine of 0 radians, right? If I plug 0 in there, I got to find the sine of -pi7 radians. I can't do that with what I know. So I do not want to plot points. I hope I made that part clear. Here's what you do want to do. Notice patterns. Now, you noticed patterns already on functions like this, didn't you? When you were given stuff like y equals -2x plus 3 squared plus 5, didn't you learn, oh yeah, that means I'm shifting up 5. That means I'm shifting left. Oh, this means I'm stretching it. It's getting skinnier. Ooh, that means I'm going down. Oh, this part means it's a parabola. You've already learned about that stuff. It's very similar to what we're doing here, but here we're trying to find out what a period of the graph looks like. And if I can find out what that looks like, I can just keep doing it again and again to graph this thing. I call that period the box. Your goal is to figure out where this middle line is. From the middle line, you're going to figure out how high or how low am I going. That will give you the top and the bottom. Then you're going to figure out, where do I even begin this curve? It might be there. It might be somewhere else. And then you're going to figure out, how long is this process? That's called the period. These 4 things you're going to find. And they have different names than shift up, shift left, reflect, whatever. So we're going to learn these. But here's the beautiful part. If you can do those 4 things, then you'll be able to graph any sine, any cosine, any negative sine, or any negative cosine. Because every single time you finish your box, a positive sine curve looks like that. Whether the box is this, and this is what I'll show you in a second, whether your box ends up being really tall and skinny, whether your box ends up being very thin and long. For every one box you have, if it's a sine curve, you will always have this. At the left part of the box, on that left side, it will always be right there in the middle, right there in the middle, right there in the middle. At the very right end of that middle line, it will be right there, right there, right there. In the middle of these 2 dots, it will always cross again. This is positive sine. So you'd find the middle, or you'd find the middle. And then once you have the 3 dots, a positive sine will always bump up and then down. And if it's a negative sine, same 3 middle dots, but it bumps down and then up. So if this was my curve, I would find the middle of that and go up, the middle of that and go down, the middle of that and go up, in the middle of that and go down. And then all I have to do at this point is come in here and do the best job I can of connecting the dots. So sometimes my sine curve is going to look very, I guess, normal. Sometimes it'll look very long and skinny. Sometimes it'll look very tall and compact. But those are all affected by your A, your B, and your C, and your D values, which we're going to talk about in a second. But the key is, can you make the box? And the only difference between this and a cosine, again, is where sine has 3 dots on the middle, or basically starts here. Cosine, positive cosine, starts high. Positive cosine starts high and finishes high, and it dips to the bottom and crosses in between the highs and the low. And then negative cosine starts low and ends low, comes up to the high in the middle, and crosses in between the highs and the lows. And the reason why I came up with the dot method was a long time ago, I had these 2 kids. One was Jimmy and one was Charlie Bong. And I may have talked about them. They had the worst handwriting you've ever seen in your life. And I mean, I've got some people that have some filthy, terrible handwriting. I got a girl in my senior class whose handwriting is just, I mean, it is atrocious. Like in the last 2 weeks, she's been trying to clean it up for the AP test. Some of you are looking at each other like, your handwriting stinks. You have no idea. Like, just to give you an example, like this is a 4. Here's a 6. No. Here's a 6. Here's a 6. Here's a 9. I mean, like, it was the same. 1/3 of all, 3/10 of all the numbers on the planet looked the same when they wrote it out. And when it came to drawing trig functions, oh my gosh, it was horrible. So I was like, okay, I really do think they were brilliant kids. One went to Stanford, one went to Duke. Really brilliant guys. But I think they might have had like a diagnosed handwriting condition, like dysgraphia or something. But because they were so smart, they always got a pass. I don't even know what the English teacher did. But anyway, I came up with the dot method. I was like, dude, just put the dot. Can you put the dots in there? Like this would be their product. This is what their work would look like. They'd come in there and they'd be like, all right, get this thing in there. You know, they might get that written out. And I'm like, all right, can you get some dots? And they'd be like, all right. And they'd get the dots in there. And then this would happen. Be like, I mean, it was the worst. I mean, it didn't even show up here, but it was the worst thing you could imagine. But I was like, dude, if you can just put the dots in there, I'll know what you meant to do. So you'd see these dots in here, and maybe he misses a dot there, misses one here. I mean, they could not control their pencil. It was bizarre. But at least I knew what they meant to do, the dot method. Now, I have people go, man, I don't need that. And they come in here and they do this. They get a nice, perfect little box. They get the box in there and they go, all right, sine curve, right? So it bumps up and then bumps down. Well, I am going to give them credit for having the right high and low, middle, beginning, and end. I'll give them credit for that. And then I'm going to look at it and I'm going to go, all right, you're supposed to start here. Great. You're supposed to end here. Great. You're supposed to be crossing right here in the middle. Not great. You're supposed to be peaking at the high right there. Missed it. You're supposed to be dropping at the low right there. Missed that. So they're going to get nickeled and dimed. Now, granted, if it's a sine curve and they did most of that right, they might get dotted. But if you put the dots in there, right, and then the pen just gets a little away from you, at least I know that you know where you meant to go. All right. So I would encourage you to put the dots on the boxes for sine and cosine. Now, it's going to be a little different for tangent and cotangent. We're doing that tomorrow. But for sine and cosine, that's it. So your goal is to figure out, how do I get these beginning and end, top, middle, and bottom of these boxes? That's what I'm giving you right here. Every trig function is going to look something like this, okay? You're going to have some lead number. And by the way, if you're wondering why they went D, A, B, C, this is the way it looked like when I was a kid. You'd have some positive of a negative A value. They would write it like that. But kids were getting confused early on, like in Algebra 2. Like if I were to write this equation, y equals sine of x plus 2, there were some kids that knew, oh, that's the sine function moved up 2. But there were some that were actually thinking, oh, that's the sine of x plus 2, go left 2. And it was messing them up. So they thought, well, why don't we just take the 2 to keep this from happening? Why don't we just put it out front? That's why the D is now out front. And that's why they didn't bother changing the letters in most textbooks. But for you guys, identify the letters, what they are, and then use them. This is telling you how you're going to use them. So the first thing you're going to look at, you're going to start with the D. Vertical shift. The vertical shift is how much the graph is moved up or down. That's your middle line of your box. So if it's 2, go up 2. Put a dotted line in there. That's the middle of the 3 horizontal lines on your box. And you've got that taken care of. And once you do that, you never have to use D again. Second thing you're going to do is you're going to use A. Now, A is the absolute value of whatever number. So we're going to ignore the plus and the minus for now. That's going to determine whether it's a positive sign or a negative sign. Okay? So ignore the sign. A is always positive. It's a length or a height. So A tells me how high or low, everybody with me? How high or low I go from the D value I just marked. So if your A value, say, is 4, you go back to your D value, wherever it is, and go up 4, mark another dotted line, down 4, Mark another dotted line. Now you have the top, the middle, and the bottom of your box. Your box is halfway complete. The third thing you're going to do is figure out where it begins. It's not always going to begin on the y-axis or have the x-axis. So the phase shift is where I was shifted. Now, here's why this is a little bit different than what you're used to. You're used to stuff like this, right? Y equals 2 square root of x minus 3 plus 6. And you can look at this and go, shift to the right 3. We've been calling that a horizontal shift, but in trig, it's called a phase shift. So we would, right here, if this was x minus c, I would go to the right c. If it was x plus c, I would go to the left. But this has got a b in there. Now, we don't graph functions that have stuff like 4x minus 3, do we? Because those don't fit our rules. But they do fit the rules of trig. So we need to figure out where that graph was shifted. Well, it's super easy. I could have taken this and set it equal to 0 and solve and gotten 3/4. Well, that's what I'm going to do. I'm going to take this, set it equal to 0 and solve, and that tells me what my phase shift is. This right here, I don't know that I would do that for most of you starting out. Figure it out on your own, all right? But that's what I would do. Set it equal to solve. I'll do that a couple times. That is the beginning, or that's one side of a box. I always call it the beginning of the box, but what's the beginning of one is the ending of another, depending on which way you're looking. But that is one location of a beginning or end of your box. So mark that with a vertical line. If it's positive, go to the right, negative, go to the left. And then the last thing is your period. Now, your period down here at the bottom is a length. Now, I should have written length of period here, but it's kind of long. So just remember, the period is the length of your box. It's the length that it takes to complete one whole period of the graph or one whole cycle. And all you have to do that is take 2 pi. And by the way, 2 pi works for all the trig functions except tangent and cotangent. We'll talk about that tomorrow. So it's 2 pi divided by the whatever the b is. So the b actually gets used twice, with the phase shift and with this. And that tells you the length of your period, which is a little tricky, but we'll get to that. Now, once I mark the length off, I just go from the phase shift over and mark the length. I've got my box. And once I have my top, middle, and bottom, left and right side, if it's sine, I sketch the 5 points on a sine curve. If it's cosine, I sketch the 5 points on a cosine curve, connect the dots. You think you're tracking with me a little bit? Okay, I'm going to skip over a few pages of talking about all the other trig functions, and I'm going to go to this classwork. I think it's on page 71. So here is a sine, a positive sine function. Okay, so I'm going to ignore the plus and the sine for now. All right, where you see the plus and the sine, I'm going to ignore that for now, but that's what I will be graphing in the end once my box is set up. So here is my thinking. What's the first thing I look at? D. I even listed them in order for you. Your D is what? -2. So I'm going to go down 2 right here. That's my D value. And I am going to mark a dotted line. And that is like my new x-axis, which is the middle horizontal line of my box. All right. So I got one part of the box complete. What's the second thing I look at? Just going down the list. A, my amplitude. My amplitude is 4. So that's my A. The amplitude is what I go up and down from my new vertical shift, my new D. So I'm going to go up 1, 2, 3, 4. And I am going to go down 1, 2, 3, 4. Okay? And I'm going to mark that also with horizontal lines. And that gives me the top, middle, and bottom of my box. What's the third thing I do? It's in order. What's the third thing I need to find? The what? What do we call that? A phase shift. So I need to find basically the beginning of the box. How do I find the phase shift? The phase shift, take this, set it equal to 0, and solve for x. Now, watch this. First thing, nobody has trouble with this. I'm going to add a pi over 2. Now, let me show you what people do wrongly here. It happens all the time, and it messes up their graph. They come over here and they go, all right, I got to divide by a 4. This is wrong, but just watch. If I divide by a 4, that 2 cancels with that 4 and gives me pi over 2. And then they just totally miss this. It is not pi over 2, it's pi over 8. Here's my advice. What you're really doing here, and I think you can see this if I go back and redo it. I'm really taking pi over 2 and dividing it by 4. And how do you divide by 4? Multiply by 1/4. And what does that give me? Pi over 8. So my advice is, if you have any kind of struggle, you look at that and you go, yeah, I would have done that. Don't divide by 4. Just multiply both sides by a 4. And a 1/4, and you'll see it's pi over 8. Now, where is pi over 8? It's positive, so I know it's on the right side. Well, it's going to completely depend on what your graph is labeled as. If I tell you that you can see right there, that's pi, right? 3.14 approximately. So this is telling me to go to 1/8 of a pi. Now I'm going to be pretty nice. I'm not going to divide this into thirds and have 3 tick marks and tell you to go to 1/8. So you can see this is actually divided up into 8, isn't it? So 1/8 of this would be right there. So 1/8 pi, if it was -1/8, I'd go -1/8. Does that make sense? Okay, so that's my phase shift. I'm going to mark off that beginning of that period or the end of another one, whatever. Now, the last thing I got to figure out is what? What is my period? Now, when I say period, I mean length of period. What is the length of a period for sine and cosine based on your notes? What is it? 2 pi over whatever the b value is. Your b value in this case is a 4, right? Yep. So that gives me pi over 2. Now, here's where you got to be careful. Length of a period doesn't mean to go to pi over 4. It's telling you that's how long it is. Are you with me? Now, on this particular graph, pi was how many tick marks? It's all about the tick marks for length. 1, 2, 3, 4, 5, 6, 7, 8. So how many tick marks would be a half of a pi? 4. That's what you're going to be doing. So this is right there. That right there is 4 ticks on this graph. On another graph, it might be 10 ticks or 2 ticks or 1. You have to think about your graph and count those ticks. So what you're going to do is the length of the period beginning here is 1, 2, 3, 4 ticks. That's one period, 4 ticks. And I'm going to go and mark the end of the period there. And there's my box. Now, you guys are going to have to graph 2 boxes on every one of these, not the whole thing. So if that is one period is 4 ticks, I could go 4 more ticks, but that puts me off the graph to the right. So I'm going to come back this way and go 1, 2, 3, and I'm going to mark my other one over here, which is not 1, 2, 3, but 1, 2, 3, 4 ticks. So you can see my 2 periods I need to graph. I don't have to worry about any of the rest of it. I will graph the whole thing because I don't know which periods you're choosing, but you only need 2 periods to sketch these. So here we go. Positive sine curve. What does a positive sine curve do? It starts right there in the middle of that vertical line and bumps up and then down. So here we go. Here's a period. I'm going to start right in the middle of that. And I know that what? Starting in the middle means I'm going to end in the middle of the other side. And it also means I'm going to cross in between those, giving me those 3 like Orion's belt dots on the sine curve. And then since it's positive, what do? I bump up, so I go to the middle of that up, and then I go to the middle of that down, and I connect the dots. So I do the best I can, my non-Charlie or Jimmy Vaughn impression. I connect the dots. And when I do another period, I do it again. Start there and there in the middle, halfway up, halfway down, connect the dots again. And there's 2 periods of a sine curve. Not too bad. First time maybe. Let's try it again. And remember, cosine, same exact process, except in the end, I have a different curve in the box. All right, here we go with cosine. And that's the only practice we're going to do, and then we'll call it a day. So right here, what's the first thing we look at? The D, and the D in this case is a what? -1. So for -1, I'm going to come in here and go down 1. Y'all tracking? That's my D value. What's next? Hey, you're literally just kind of moving across, right? Your next one is A. Your A is what? 3, not -3. Just say 3 because it's a length, right? So the A is 3. So that tells you that from here to go up 3 and down 3, those are that's marking off my amplitude. So up 3, and remember, I'm not doing that from the x-axis. I'm doing that from my vertical shift, my D. And it says all of that in those notes. Now I've got the top, middle, and bottom of my box. So far, so good. Then what do I do? What are we finding? Phase shift. So my phase shift, how do I find it? I set that equal to 0. This is like my shift left and right, okay? And you can't just look at this and go, oh, it's positive, so I'm going left pi over 2. The 3 affects that. So I'm going to set it equal to 0. That gives me 3x equals negative pi over 2. So I am going left. And then what do I do to get rid of the 3? I like to multiply by 1/3 because that doesn't give me any confusion on that right side and gets me negative pi over 6. Now, last time it was pi over 8 or 1/8 of pi. Now what is it? It's left 1/6 of a pi. Well, where's pi? Here's pi. There's pi. How many tick marks does it take to get to pi? 1, 2, 3, 4, 5, 6. So I want to do 1/6 of those, but left. So I'm going to go left right here. That is my phase shift. So I mark that down. So all I got left is to figure out how long this period is or how long this box is. So how do I work with period for sine and cosine? Remember, this is the length of a period, even though I only wrote the word period. How do I do that for period? 2 pi over the b value. So I take 2 pi, I divide it by b, which in this case is 3. So my period is that length, right? Length. Now, remember, every ruler is different. So what is pi? Pi is 1, 2, 3, 4, 5, 6 ticks. So if pi is 6 ticks, I want 2/3 of the 6 ticks. What's 2/3 of the 6 ticks? 4 ticks. So that again represents 4 ticks, but for an entirely different reason. I'm taking 2/3 of that. So if you want, you could just think, oh, there's 6 ticks. Let me go 2/3 of 6 ticks, or before it would have been 2 whatever of 8 ticks. So 4 ticks, that means don't go, guys. It doesn't say to go to 2 pi over 3. It doesn't say to do that. It says go 4 ticks from beginning to end. So from beginning to end right here, beginning to end, that is my period here in the blue. So I mark that ending, and there's my first box. And if I want 2 boxes, I can either go to the right or to the left with plenty of room, right? So if I want to go to the right this time, I'm right there, and I'm going to go 1, 2, 3, 4 more ticks because I know every period is 4 ticks. Now that I have my 2 boxes, can we graph it? Well, what are we graphing? Negative cosine. So what do you know about negative cosine? Positive cosine starts high, goes down. Negative cosine starts low and goes up. So I'm going to start low. I'm going to start low and end low in each box. I'm going to peak right there in the middle, And then in between the high and the low, I mark points. Still doesn't show up greatly. All right, so there. And none of this really looks that good. Let's go black. Those are my 5 points. And then I come in here and I just connect the dots. And if I need to do it again, start low, end low. In the middle, I'm high. In between the high and the low, I cross. And there are my 2 periods of a negative cosine. So I didn't do a negative sign or a positive cosine, but again, get your box, think about what it's doing. Y'all with me? All right. Here's all I have. Knock yourself out.
Handle.
I think you have in his packet, right? In that time? I don't think that rings a bell. So I'll give it.
That's not.
Yeah, you can turn it if you want. If we end up shutting it down, then I'll just hand it back to you. No worries.
You were just like, you know, everyone heard him. You probably didn't hear me, but you heard me. They didn't know it was today or something. Is this what we're doing today, Mr. Hurd? I think so.
Learning. So I will not be here Thursday.
I'll do that. I'll get off. Here you go. You put it on like this. Put it in the bottom. It's time to get my customer. Thank you. I'm so glad I didn't have to spend. I didn't even know we were having a workout test yesterday, and then I got a B6. She sounds put on a grade. Put in the grade for the homework last night, so. What? Yeah. You might have been proctoring.
Everybody.
Everybody. We're supposed to carry these places. There's two sides to it. Yeah, we're missing like almost a third of the class. Kieran and Chris. Yeah. I would have thought I would check out. That makes it cute.
It's unfortunate. Well, we must go.
The show must go on.